Everybody, welcome and thank you for joining. It's my pleasure to introduce the ISEA webinar. Before I introduce the speaker though, I'd like to invite you to join the ISEA organization if you haven't already. You can go to ISEA-Change.org. On that website, you can read more about what statistical engineering is, what the International Statistical Engineering Association does, and of course, you can become a member if you'd like for no cost at all. Okay, so let me introduce Dr. Diego Kuonen, the founder of the Statu Consulting Service, where he regularly consults on applying statistical engineering and thinking to big data analytics for businesses and government bodies in Switzerland and across Europe at the operational, tactical, and strategic levels. Additionally, he is currently a professor of data science at the Geneva School of Economics and Management at the University of Geneva, Switzerland, and he's a founding director of the school's Master of Science in Business Analytics program. He is also currently the principal scientific and strategic big data analytics, data innovation, and data science advisor for the Directorate and Board of Management of the Swiss Federal Statistical Office, and he's ranked within several global big data analytics and data science top 100 influencer lists, and he's very active on Twitter. And since 2021, he's also become a member of the ISEA board. So I'd like to please join me in welcoming Dr. Kuonen, and he'll take it from here and talk to you about his journey towards becoming a statistical engineer. Go ahead, Diego.
Okay, thanks, Nathaniel, for this introduction. So it's a great pleasure to give you a little bit my journey towards becoming a statistical engineer. And basically, the last thing, as Nathaniel ended now, I was also a very proud member of the board of the ISEA. And the journey starts a little bit by explaining a little bit about my background. And my background is basically in engineering school. So, which is basically at the Swiss Federal Institute of Technology. At the time, it's called nowadays a Master in Mathematics. I received in English translation a mathematical engineering degree. It was back in '98. So it was really an engineering school. So this engineering mindset I always had basically in my head. Then I started doing all courses on statistics. So I got my PhD in statistics. And in 2001, I had this feeling everybody on this planet needs statistical thinking. So I created my own company. So as you see now, it was 20 years ago. And this is a little bit where this statistical journey or this statistical thinking journey started at some point, because one of the most influential books I ever read was a book by Roger Hurl and Roland Snee on statistical thinking. And this 20 years ago, it opened me completely new ways of thinking, having my PhD in statistics and my engineering background at some point. And this is basically what I started 20 years ago. And through time, through experience, I was also then appointed by the University of Geneva. This was another milestone somehow in my journey, where I basically tried to bridge the gap between what I call the real world and academia, and also basically my main activity being my consulting company. This is also in this role I'm consulting since several years, the Swiss government, including the Swiss Federal Statistical Office. So a lot of points here you will see throughout my journey, going back really 20 years, what happened, how statistical thinking, what is statistical thinking about, how statistical engineering, how the work which were already done by people like Hurl and Snee influenced a little bit my career, and really became towards becoming a statistical engineer, which is at some point my best job description. Before going on with this, I'm going to show you here a cartoon of a friend of mine who has a PhD in statistics, which is Enrico. As it was noted, I'm from Switzerland, and originally I'm from Zermatt, which is the village at the bottom of this famous mountain here called Matterhorn. And he once drew me this cartoon to illustrate maybe why I became a professional statistician. So during studies, I learned on this very well-known normal distribution. With 20 years of practical experience, I also had it to accept somehow it's a myth. It does not exist in the real world. Nevertheless, the love I have to the mountains and to my orchards is still there. So if COVID a little bit is down, so if you never were in Switzerland, you've never were in the Swiss Alps, it's a good opportunity to once go there, and maybe then also we could meet in person. So let me start with a quote from John Tukey, who did wonderful works in the last century. In one of his most famous articles about the future of data analysis in 1962, he wrote the following, and this strongly influenced a little bit the way how I perceive things. Statistics has contributed much to data analysis. In the future, it can and it should contribute more. And now, for me, a key element in his sayings is really the point here. He said it's not about only providing new techniques, or better tables for all techniques. So it's no need to provide new techniques in order to provide, to influence the practice of data analysis. And this is also why basically one of the things I didn't really want to follow an academic career, but I wanted to get people influenced, to get applied statistical thinking everywhere. And this is basically why I started the company 20 years ago. Once in 2015, the membership magazine of the American Statistical Association asked a question on Twitter, as a statistician, what was your superpower? And what I wrote then on Twitter was applying statistical thinking and statistical engineering for continuous improvement. And I was then quite happy to see that in September this was taken up in the magazine and was printed out. And as you see here, there are like two elements here. So what is statistical thinking and what is statistical engineering? So let me start with the first thing to give you an idea what is statistical thinking about. Samuel Welks is known to be said that it will be one day as necessary for efficient citizenship as the ability to read and write. But what was really meant by statistical thinking, or how did I think about when I came after works which were done Hurl Snee and others 20 years ago, what did influence my journey? It was really this definition here, that statistical thinking is a way of learning, it's a philosophy, it's a mindset. It has three simple principles. The first one, everything is a process. A process brings things, turns inputs into outputs. Second principle, variation. Because we have variation, we have uncertainty in decisions, for example. And variation exists in all processes. And now the third element is, why do we have this understanding? Why we have to get an understanding of the sources of variation? What are the drivers of the variation? And we have also distinguished between there is variation we need to run the processes, but there are variation which are not good for the processes. So the ones which are not good at some point we have to reduce, we have to understand what's going on. So these three simple principles has nothing to do at the heart, it's really a mindset. You can use this as an excuse next time if you're late to a meeting. You can say, okay, it's a process, stepping up, going to the meeting. If I do it tomorrow, we will have different timings. Now, third principle, why do we have this? If you want me to be on time, I have to do this and this. So this is common thinking. This is a mindset, and this is what really a philosophy of statistical thinking. And it has really key components. It has the process thinking, viewing everything as a system, as a process. The second one is really the managing of the variation and hence the underlying uncertainty. And if you want to do it data informed, you have to use data where possible to guide actions and to improve decision making. So it's really an overall approach to problem solving and improvement. Deming once said, if you cannot describe what you're doing as a process, you don't know what you are doing. This really puts in line this first principle. This is the process thinking. Nowadays, if you want to apply AI somewhere, you have to first understand the process where you want to apply it before you understand the methods of AI. So you have first to have this processing. So we had this idea of statistical thinking. So are there key principles? So this is on one slide. It's borrowed from a lot of work which was done by her, Snee, and others. And it always tell people this is like a summary of my 20 years of professional experience. Do not neglect the following 4 principles. The first one, it's about continuous improvement. It's about doing it iteratively in a sequential way. You just cannot take a piece of data, you get all answers out, and you're done. It's about continuously improve, about continuously aim for better search of solutions to problems. So this is a sequential approach. The second one is you have to have a strategy why you want to do this. Not a strategy from a statistical point of view. You have to have a way within a company how to tackle this thing strategically from a company perspective, from a research perspective, whatever. So you have to have this strategic thinking. And the third principle, you have to carefully consider the data pedigree. This is the pedigree, the data before, during, and after the analysis. And the fourth principle, you have to apply sound subject matter knowledge, domain knowledge, business knowledge. That are all those consulting companies, board of directors, and what I was telling them, you have the subject matter knowledge. It's not an external company who has it. So you have to activate your minds. You have to think about what are the processes, how to define the problem, how to assess the data pedigree, how to guide data analysis, how to interpret the results, where to use this, etc. So these 4 principles are really key to analytics, or today any data in our data science, you name it. The first principle with respect to continuous improvement is really related to what once Joseph Juran said, all improvement takes place project by project and in no other ways. The world of proof of concepts for me is over. You cannot make a proof of concept and you know whether it's working. It could work, it could not work. Any problem you encounter is an opportunity to do it better next time. If I put here the words of Henry Ford, he once said, failure is only the opportunity to begin again more intentionally. This is exactly this. Nowadays, you have the digital transformation, you have the data revolution. So it's a little bit this idea of fast test and learn approach. You have to get to fail very fast, you learn from it and you move on. And this is what continuous improvement is about. It's not a sprint, it's really a marathon, it's a mindset. Because you accept that every problem is an opportunity to do it better next time. And this is really this continuous improvement. And as such, as it also taking now the statistical thinking approach, continuous improvement is a process. So you have to understand the process first. This also means it has to be governed, it has to be managed, continuous improvement. This means you have to have top management commitments. That's also why we need the strategic thinking part. It's about allocating resources, eliminate roadblocks, promote the concept of prevention through the organization. And if you start implementing this, you are on the way to your never-ending road of continuous improvement. And this is really this idea about, which was the first thing about the continuous improvement. Let me get a little bit more in detail in the second one, which is strategic thinking. And I put here a quote from George Westerman in a Slow Management Review article where he said, you don't need a digital strategy, you need a better strategy enabled by digital. You don't need to have an analytics strategy. You need to have a business strategy where analytics is a key part of it. You don't need data strategies. You need strategies, business strategies, which incorporate, which are linked to this. Because it's not about technologies. It's not about tools. This will change too quickly. it's not about using this or this tool, this technique, even the statistical one or machine learning technique. It's not about this. These things change. So you really have to focus on the transformation and not on technologies and tools, because then it won't be sustainable. And this brings me a little bit to on my journey when I started doing consultancy over the years in private companies. And then in 2016, I got contacted by the Swiss Federal Office to go a little bit outside new data sources, applying machine learning techniques to an existing data sources. And what I convinced them was to really create an office strategy. So now a strategy, a top-down strategy for a Swiss Federal Office, which was called Data Innovation Strategy, which is available on the link here. And I was told you will get also the slides afterwards in English, German, French, and Italian. And it's a data innovation strategy. And how was data innovation defined? So it's the application of complementary methods. So these are methods which so far were not used. So the office existed more than 160 years, similar to the US Census Bureau, if you want. But the focus on the strategy was to augment, to complement the existing production, the existing factory. It was not about creating something like in a separated silo, etc. The idea was starting with process thinking, clearly having an idea where could it make sense, where are gains in quality, where are gains in efficiency, which processes could be complemented, could be augmented by using techniques, analytics methods, especially predictive analytics, techniques from machine learning, from data science, from advanced statistics. And this is a little bit where the journey started already from 2016, so more than 4 years ago. And towards the end of the presentation, you will see a little bit how the future will look like and how this is then fully in line basically with what I present you throughout the journey with my job as statistical engineer. Okay. One element I also noticed over the years, and this won't surprise you so much, you can have the best strategy on the planet. Culture eats strategy for breakfast, lunch, and dinner. And we are again, if you want to make this digital transformation, the transformation is first a cultural transformation. It's a change in thinking about things. It's about a culture that supports the change while enabling the overarching business strategy. So do not let culture eat strategy. As Deming already told us in 1982, this transformation can only be accomplished by man, not by hardware, computers, gadgets, automation, new machinery. A company cannot buy its way into quality. It can only be accomplished by humans, by man. So if you have now a little bit this idea here, what statistical is thinking about, what are the key concepts, once again, continuous improvement, strategic thinking, the data pedigree, the business context. Somehow over the years, I had a little bit of feeling something was missing. And there are a lot of opportunities, needs for improvement in the 21st century. Here's some of identified by Sneha and her in a wonderful article on the future of quality, where you have at the bottom leadership, strategic thinking, this quality culture. Now we have big data, these data-rich issues, mission-critical problems, complex problems. We have the human variation. We want to get holistic improvement, improve results, jobs, and more jobs. So these are a little bit these needs and opportunity for improvement. And over the years, when I started applying also practicing thing, I had a little bit of feeling something was missing. We have now nowadays all these tools around on the operational level. You have at the top strategies, it's like a pyramid, and there was something missing in between. And this is exactly now, which brings me to the next point, where this engineering mindset comes in. That's why my best job description, I once put this on Twitter. I'm a statistical engineer. And what the hell is a statistical engineer? A customer, a client comes to me, and I try to best use data, analytics, for example, statistics, data science, machine learning, AI, concepts, principles, methods, and tools. And as you see here, they're not only statistical tools, they're also non-statistical tools. And I would like to integrate them with IT and other sciences to generate improved and sustainable results and to enable continuous improvement. And this is really what statistical engineering is about. Taking here the definition from an ISE webpage, it's a study of systematic integration of statistical concepts, methods, and tools, often with other relevant disciplines to solve important problems sustainably. When I speak about people about statistical engineering, I always tell them it's not only statistical concepts, it's also non-statistical concepts. Any concept, method, or tool which could make sense to solve the problem. And this is this engineering mindset, I think, which is at the heart. So how are these different links related? So this I can show you here on this pyramid. Basically at the bottom, you have the operational thing. You have statistical methods, you have tools, you have non-statistical methods, you have methods from machine learning, from AI, you have data sources, you have all these operational tool methods, gadgets, techniques. At the bottom of the pyramid, you have the strategy. Where you want to go, what's your mission, what's your vision, how you perceive, how you want to serve customers, how you want to do research, etc. And currently what's missing is the link between these both worlds. And this is this tactical, which is the engineering mindset, where you think about, I have a problem to solve. Okay, these are my tools. How do I put all these tools together? All the teams I need, the humans I need, the different pathologists, the different backgrounds, different data sources. How do I engineer these things together in order to fulfill the mission, in order to solve the problem? So I need to have this engineering mindset. I need to approach this from an engineering point of view. And additionally, this engineering mindset, because this is what you are trained as an engineer, you want to solve problems. And I know now from a marketing point of view, I have enough experience now also in banks, etc. If they say we need to have more engineering, they look at you, okay, but this is too technical. It maybe also think about how you call it. That's why, for example, in the FSO strategy, we didn't call this machine learning techniques, we called this complementary methods, because this term was not used so far. So I'm not giving here now, I speak about whether it's a good or a wrong name, but what's really important is that you have this engineering focus, and this engineering perspectives really provides a clear focus on problem solving and on continuous improvement. It really shows you there are people who come in, there are different tool sets, and you have to engineer them together in order to try to solve problems better, faster, to derive solutions, to go for sustainable solutions, and really to jump on this continuous journey, continuous improvement journey. And it's clear, as you already see here, this is a teamwork, team of people, team of tools. And Sun Tzu, in his book, The Art of War, he once said, if you do not seek out helpers and allies, then you will be isolated and weak. So with what I've shown you so far, I wanted to give you a little bit an overview of what is statistical thinking about, what is basically statistical engineering, why is statistical engineering nowadays needed much more than before. So let me give you now a little bit what I made out of these things. And going back first with what I did when I was appointed 2015 at the University of Geneva in a business school. And they asked me, you want to give a course on statistics? Yeah, wow, cool. I thought, no, I don't want to give a course on statistics. I create a new course. And I created a completely new course, which is called Business Analytics. And this completely new course had the goal. I wanted to get them to provide them with an overall problem-solving and continuous improvement strategy based on statistical thinking. So it started in 2015. So it was a completely brand new core, brand new. I didn't have a textbook except what I called one of the best books on this thing by Hurl and Snee. This is the 3rd edition. Here is the 2nd edition, which is really a little bit this idea of statistical thinking. I started with this, also with discussions I had with Roger Hurl on how to do it. And I start doing a bachelor course. So every year now I have more than 250 every year. So since 2015, more than 1,000 students. And remember, this is it's a management school where I am. And the idea is to prepare the undergrad students for business leadership by developing capacity to apply statistical thinking to improve business processes. And if I show you now, basically, what I get trained those, so this is basically taken from Hurl&Snee's book. This is what I train them about. On the left, you have this overall process improvement strategy, where you start by understanding the process, collecting data, access process stability, special cause variation, etc. And always on the right, you have the tools. And I train them on what are flowcharts, how to do a simple 5 whys, for example, for problem solving, how to do affinity diagram, how to do multi-voting, etc. I don't train them on experimental designs, but I give them a little bit idea also from how to do the statistical part. And basically the prerequisites they have, so remember this is a management school, they have an introduction to maths course, they have an introduction to probability course, and with all these things, I try to engineer what they can do now with this. And the product is this course. So I do not introduce new statistical techniques or new mathematical techniques. I try to look what they had in the first year, and I try to engineer at some point the thing now with what you had in the first year. This is what you can do with respect to process improvement, with respect to problem solving. If you want to have more details of the course, feel free to send me an email. Just to give you an idea about the contents, this is directly taken from the first slide. So I start by introduction. Why do we need business improvement? We have 2 jobs. You have to do the job and improve the way how you do the job. Then clearly the focus in the course is on statistical thinking. So I explain them what statistical thinking is about, what are the principles, ever in detail. So what is really process thinking about? Why is it important to understand variation? Then what is a statistical thinking strategy? I add a lot of experiments Deming did. These famous experiment, red bead experiment, funnel experiments. I speak more in detail about the variation in processes, then about stability, capability, what are control charts, how they can use really to track customer performance, how to choose really a little bit control limits, how to access then also capability. And at the end, it's like the big picture. I provide you now with all tools you have seen. Most of them, the non-statistical ones, are the ones which are somehow new. This is how you can tackle process improvement, how you can have strategies to solve problems. And at the end of the course, I give them some introduction to observational business data, affinity groups, recommendation engines, what this thing is about. So this is a little bit this thing of this course here. And really what I really try to get them, and this is one, they also get listening to this thing a lot of time. It's getting better, a little better all the time, the song from the Beatles. And really what I try to brainwash them is that every problem is an opportunity for improvement. So I started this course in 2015. So it's a 6 credit course, ETCS course. It's a full semester course, every year around 200, now this year more than 250 students. And now came COVID, and I took this opportunity, and I made now out of this a complete flipped classroom with 300 students. And it's a wonderful experience because now I really see the interaction, how they understand the concept. I really can interact with the students by asking them quizzes and stuff like this, whether they understood the concepts, with the goal always to continuously improve the contents as well. And this even drives me on doing courses. I want to continuously improve the content to make the experience much more pleasant, in this case for the students. Because at the end of the day, if it's not brainwashing, if they can make them think statistically, and they will have afterwards managing position, and they will remind themselves about this course, then I think this is beneficial for the complete profession. This is, if they think then statistically, this is wonderful. So this is a little bit the motivation. I didn't stop there in the journey in the university. What I did then, I told myself there needs to be a new master program, not only a bachelor course. So what I did in fall 2017, I created a completely new master program. To what? To empower students with the statistical engineering skills. Really reading through this statistical engineering works which were done, the engineering, really provide them with the statistical engineering skills. And this is also, it's not a master in data science or a master in statistics. It's really, I have the luxury, the business schools, we have IT people, we have management people, we have statisticians. We have also strong collaborations with other faculties, for example, the Faculty of Law. And we decided about to making, like an engineer, a new master program to do what? First of all, over 2 years, so it's a 120 credit program, support students to manage, analyze, and data and strategic, tactical, operational decision, prepare students for leadership position, and bridge the gap between the university education and professional needs. And this bridging the gap is really taking place in the second year. I'll show you just in a sec. What I did then the last year, and I drafted the learning goals and all learning objectives, which are available on the web page. So if you Google this master program, I just put you here the learning goals. So the graduates will have the critical, responsible skills to engineer sustainable solutions to large, complex, and unstructured problems. From root cause by taking, from symptom to root cause by taking into account ethical and societies. This is one learn course. Every learn course has around 4 objectives. So it's really the statistical engineering skills to engineer solutions. But not only the critical and responsible thinking skills, also the data and analytics skills. This is the second learning goal. And the third one is really leadership skills. So really the management side. And the fourth one is really communication skills, soft skills, etc. So this is a little bit the 4 learning goals. We have now there are all learning objectives, and we have underlying courses. So let me give you just an idea about how to fulfill this. So it's a 4-semester program. The first year basically are core courses. So everybody has to take these courses. There are prerequisite courses, and one course that you will be surprised is my bachelor course, Business Analytics, where's the statistical thinking mindset. And then there you have core courses like course, computer science course on algorithmics data management. We have creating values through data mining, which is currently given by an MIT professor. We have a course on data quality and data collection, on quality improvement, which I give myself. We have a course from a management marketing professor. We have a course analytics consulting, which I also give myself on the soft skills. We have a course on machine learning, prescriptive analytics course. We have a course given by a law professor on privacy and data protection in digital economy, and an advanced course in computer science. So they have these, like they call the engineering, the elements they need to be able to engineer solutions. And then in the second year, in the third and the fourth semester, there are basically 2 options. One option is this classical master thesis thing. And what's new here, this is called the dual program. It's one of the first dual programs in Switzerland, where the second year they do 10 months internship in a company solving real world problems by having the background of the year for the first year of studies. So they do really an internship, and they take some additional courses like a management course, etc. But roughly 10 months they're doing internally to a company, a multinational company, an internship. So when they're added at the end, they have their Master Science in Business Analytics over 2 years. And I have the feeling they have the needed the basic statistical engineering skill sets to really have first positions to engineer sustainable solutions to large, complex, unstructured, data-rich problems. Because, as George Box once said, it's about creating good managers, and good managers are like coaches who lead and encourage their teams in never-ending quality improvement. And I think by these skills we train them. So also on the bachelor's, they may not do a master in statistics or business, but at least I think they have a good statistical thinking mindset. That one day they will make decision. If the course was good, was interesting, maybe they will remember this thing. Those who do the master in business analytics will, I think, have the basic statistical engineering skills which are needed to really become what I call good managers, to really lead and encourage the teams in this never-ending quality improvement. On a little bit more strategic level, what I also started last year in Geneva, there was a new competence center which was launched on data science. I think this is now every university on this planet does. And I was a little bit helping them at the beginning at the strategic level on how to put in place the mission, the vision, and something very important, I take this on, is what is data science in this case here. So the vision here is really to apply data science to understand complex problems, to consolidate the status of scientific excellence in the area of big data, to develop skill, initiatives, and solutions for the public good. So it's about problem solving. So this is a top-level initiative of the rectorate of the university. It's not within the engineering department or whatever. The mission is really to federate, so act like an engineer. In the first version of the mission I wrote for them, I used the word engineering. They didn't like the engineering word, so they spoke about federating, putting together different pieces. And on the webpage, you also have then the definition of the term of data science. I propose them. It's the process of continuous improvement aimed at solving complex, unstructured, and data-rich problems by applying specific methods, techniques, and practices. So at the heart of data science is statistical engineering. So this started now, and now it's a big thing here. So you have to speak with everybody internally, but I helped them at the beginning a little bit to start the thing off. As I'm not, my main activity is not academia, my main activity is my consulting company, but at least I tried also to give there something back. Now going back to my journey as a consultant, I go back to this point here, which illustrates a little bit the point. Are you too busy to improve? No, thanks, we are too busy. So there are a lot of, also in the government, everybody wants to improve, but no one has the resources, everybody's too busy to improve, basically. So the journey which started at the Federal Statistical Office back in 2016 found its continuation in the creation, beginning of this year, of a Swiss National Data Science Competence Center, which was created now on the 1st January of this year. And what's this mission? So the mission is to use data science to develop skills for the public good in the whole of Switzerland. So the clients basically will be the public sector, the administrations, and limiting on public policy and public governments in Switzerland. And the idea is here as a mission to be at the crossroad between data science and artificial intelligence, to build skills, to use the appropriate method, techniques, and practices. And the services will be data science as a service. And this is now, this new Swiss National Data Science Competence Center is really for the Swiss government to act as a service provider for using and applying data science for the public good. And how was data science defined? How do we define data science? So first of all, data science is a process. It's an entire process. It starts with problem formulation, data collection, data selection, data preparation. At the heart of data science is a problem-solving process and a process of continuous improvement that aims to solve complex, unstructured, and data-rich problems through the application of data science methods, for example, methods from machine learning and the field of artificial intelligence, techniques, and practices. And this is, if you want, this is now the official definition, the Swiss government, of data science, which is basically at the heart of data science is statistical engineering. It's about solving problems. It's about solving complex, unstructured, and data-rich problems through the application of methods, techniques, and practices. And it's clear if you do this from an applied point of view, you have to engineer solutions. You have to guarantee that the solutions are sustainable. You have to guarantee now with public good, they are transparent, they're explainable. You have to guarantee, and that's why the official statistics is so wonderful. They have standards, how to work, how to be transparent, how that things are reproducible. You have everything. They learn this since hundreds of years, etc. What official statistics is about, and that's why they have their core, which really their core mindset is there. And now really the idea is with this new data science competence center, really to develop it for the public good. And as you see now several times, you may know, okay, but this is a copy of the one you had before in the University of Geneva. Just I had the pleasure to influence the writing. That's why it's similar. And this brings me really to a key point with my years of experience: common language. This is the key to success. And this is the most difficult also in the Swiss Federal Statistical Office, also at the University of Geneva, to get validated what an operational definition of data science at the strategic top level. And everybody agrees on this. Certainly not. But at least they say, okay, this was decided, so we have to adapt. And then you can speak, then the culture, the mind change starts, because then you can speak about what can we do with data science, and not the question, who will own data science? Who are the data scientists? So it really starts with having a clear definition of what data science is about, in this case here. But once again, this is on paper. Now comes all transformation which needs to play, that the agility is there, this willingness to improve, to continuously improve. But once again, this is not a sprint, this is a marathon. This is a continuous journey of continuous improvement. There is no end line. But at least the basis is good, and the common language from the beginning on is really key to success. Because you want to avoid things like this here, the speaker, was it clear, and nobody understands. Another key element is leadership. And I think leadership is about using this idea, the definition here of Lao Tzu, what a leader is. This is best when people barely know he exists. When his work is done, his aim fulfilled, they will say, we did it ourselves. This is for me leadership. And I have highly printed out this quote since more than 15 years. And this is a little bit to empower people with this mindset, to empower students, to empower companies, to empower really also the government bodies, etc., with this mindset of statistical thinking, of statistical engineering, of continuous improvement, about problem solving. This is for me a key element which motivates us. But it's clear, Aristotle once said, what we have to learn to do, we learn by doing. Having said this, if you have also questions afterwards, you can just Google my name. You can follow me on Twitter. I'm also on LinkedIn, so feel free to connect. And thanks for your attention. I give back the word to Nathaniel. And I think if he's still there.
I am still here.
Wonderful.
All right, well, thank you very much, Diego. That was a wonderful presentation, and I'll thank you on behalf of everyone in the audience who can't clap, but I'll clap for you. So we've got a number of questions here, and I'll remind the audience, if you have any questions, please use the question tool in the GoToWebinar control panel, and I'll make sure that I ask it of Diego. So the first question that came up early on when you're talking about the idea of continuous improvement and that paradigm that there's always continual improvement that can be made, a question was raised about how you feel about the sort of quote unquote do it right the first time principle and where that fits into this idea of sort of continuous improvement.
So for me, this is the case to know what you already know about the process, how much knowledge you have in the process. Because at the end of the day, it's about acquiring process understanding. You want to understand, you want to know something about a process, may it be a business process, whatever. So if you want to do it right the first time, I think you have to have a very deep process understanding to know where is the right place to do it with what tools. If you're more like a little bit in a discovery phase, you don't know exactly how the process is working, it will be possible to do it right at the first time. It's like playing a lottery, if you want. But I think it really depends how much process knowledge you already have. Because once again, at the end of the day, you want to understand better a process. Can it be a customer interaction process, research process? That's why you're doing this. That's why you're collecting data. And that's really, it's related how much process knowledge do you already have in order to know where you start.
Yeah, okay, great. There was a couple questions and comments about your program, the MSBA program specifically. One is a comment, and I think it's worth echoing for everyone here. I guess we have a recent graduate from that program in the attendance, Konstantinos, and I'm going to mispronounce this last name, Darduje, maybe.
Oh, great, yeah.
So he is an alumni of the program, and just wanted to share that in his experience since the program and in his everyday work life, the tremendous value of statistical thinking in a business context and the value of this program in terms of teaching not only just the hard and sort of necessary skills in terms of business analytics, but also the value and importance of the soft skills, the communication, and all of that being needed in order to engineer and communicate solutions. So this past student just wanted to say thank you for your role, I guess, that you played in that program.
It makes me proud, yeah. Thank you very much.
So one other, I guess, sort of procedural question about your program is there any age limit to the Masters of Business Analytics? And so maybe you can speak on that and what other prerequisites might be necessary to gain admission into that program.
No, there's no age limit. You are just to be aware, this is a full-time master program. It's not, you cannot do it and having a job beside. But there's no age limit. We have, last year we always had people which were a little bit, which really have, really, this is wonderful in the program. We have very young ones, but we already also have some which already have 20 years of business experience or even more. So there's no age limit. But however, it's on admission, so it has to be an application. So it has to have some basic courses which need to have taken somewhere on maths, probabilities, some prerequisite courses, and then it's on submission, on application, sorry. And then we in the scientific committee decide who can join. Just to give you numbers over the last years, we always had around 270 to 300 applications. And we have chosen around 40, and finally around 20-25 came to Geneva. But there's no age limit.
Okay. All right. Here, maybe I'll try to summarize several questions at once. There's a lot of chatter here about sort of the connection between statistical engineering, statistics, data science, data engineering, and you mentioned a few times when you're talking about your mission statement for the Data Science Competence Center that you sort of view statistical engineering as being at the heart of data science. So I'm wondering if you can sort of maybe express or articulate really how you see these different fields or disciplines working together, how they complement one another, whether they're just different names for the same thing. I think the audience would be interested to hear how you think through that.
Yeah. So unfortunately, I would have a slide, a wonderful slide to show you a little bit. This is like a circle. And in this circle, that's why I'm putting here, you have different elements. You start with the problem formulation. And then after this, that's why I re-put you this slide here. There comes problem formulation. Then comes the data collection, the data selection, data preparation. You analyze it, you evaluate it, you interpret, you communicate it. You think about your findings and you refine your problem. And you get this circle, like this PDC or PDSA circle from Deming at an abstract level. And this is really this process going on. And in every step, you need different skills. This means, for example, in the step where we are with data preparation, or where we think about the collection of data, we need data engineers. We need also maybe surveys that depending on what. So we need a team everywhere. And we need some team which contains data scientists, people from the domain. We need people who really can hardcore program stuff, could be in R or Python. We need people who know also how to operationalize models. So we need also operation engineers. And it's really, we need people who are able to communicate. We need people who are able to tell stories. We need lawyers at some point with respect to data protection. So it's really, we need from like engineer for a particular problem, the best team. And that's why it's really key that all elements are needed, because data science for me is not applying statistics, it's a complete process of problem, of let's call it data informed problem solving at the end of the day.
Okay, so would you equate a data scientist to a data engineer, or would you say maybe the data engineer, sorry, a statistical engineer, and then would you maybe think of the statistical engineer being the person who's coordinating all of those functions and all of those other people that you just mentioned to solve a problem, one of which might be a data scientist?
Yes, this is exactly this how I perceive this engineering mindset, that you have a team. You have on your table a team, you have data engineer, you have DevOps people, you have AI ops people, you have data science, you have statisticians, you have, depending, social scientists, depending on the domain, you have lawyers somewhere, you have these and these guys. Now comes a problem you want to solve. Now you have to engineer your dream team. And a data engineer, I think he knows enough of the different domains, who knows what are the advantages of using this one, do I need this one, etc. I think it's really about engineering these things. It's about engineering. That's why I always had the feeling before I read the first time this definition, which came out by Ernst Lee, this thing was missing so far. Really, this engineering thing, how to link these operational things together in order to solve, as a dream team, a problem.
I see. Okay. So sort of trailing off this idea of continuous improvement and sort of strategic problem solving, there's a question about, in your experience, how have you either personally or how would you recommend helping change culture in an organization who is sort of, I guess, new in the sense of problem solving and statistical thinking, and you might be qualified as in a state of chaos? How do you help a culture like that transform to one that is more, statistically minded and focused on strategic problem solving?
With my experience is that in the private sector, it has to be starting top down. So I have also with the one biggest insurance company, also with the bank, I started very top down. In the board of directors, I not brainwashed. I explained them we need a common language, we need a strategy, new business strategy. We need just a digital strategy. We need like an analytics strategy, and really then create the common language and then get it down to the people to take them with to create the awareness internally. That really, this is the way I always worked, really going top in and then going down. Now, from the bottom up, it will be difficult. So you need to have some structures in place which enable you to do this. To to make a link between, let's call this continuous improvement, this problem-solving world, and on the other hand, the standard way they're doing. Let's call it a factory. And this is currently something last year I was the honor to publish an article with Roger Hurd and Don Redman in Sloan Management Review on creating a new structure which is called a bridge, which bridges both worlds. And this is a new structure because there will always be a tension between both elements. And for those interested, you can contact me. I can send you the article, and then you might get a little bit. This may be a structural issue which needs to solve with a new structure. And this structure could then take into account to have this bidirectional communication between the ones who want and the ones who don't want. But once again, this has to be governed top down from a decision point of view.
Okay, great. All right, well, we've exhausted all of the questions that are currently there. Maybe I'll just leave this for one more minute and ask the audience one last time. If you have any remaining questions, please ask them in the chat now. While I allow for time to do that, I'll let everyone know that Diego's slides are going to be made available on the ISEA webpage. So if you would like to, Diego also welcomed you to email him for the slides, but they will be made available on the webpage if you'd like access to them. I don't see any other questions, so I'll just end by thanking Diego again, and also just making the following closing remarks. I want to thank all of you who attended. This was our first webinar of 2021, but certainly won't be the last. Our expectation is to run these every 2 months or so throughout the year, leading up and culminating with the summit, our virtual summit in the fall, specifically in November. That's going to be ISEA's flagship annual conference. And if you want to make sure that you are up to date and aware of all of the ISEA webinars and events, please join the membership. Go to ISEA-Change.org. It's free to join, and we'd be happy to have you. So thank you again to all of you and to Diego. And I think, yep, no further questions. So thank you, everyone, and we'll end here. Take care.
Thank you. Take care. Bye-bye.